Ever since a shop in town began selling photoresist boards, I've been stuck on the idea of replacing tone transfer with masked UV exposure. So in this video I'm going through the construction of my UV exposure box, and here you see me just mocking up an outline of what I have imagined. Usually when it comes to projects like this, where hard precision is not necessary, I don't do any pre-dimensioning but sort of just measure things as I go. More on that later. But I wanted a small box with some kind of drawer to replace the PCB and a lid in the front, so that we're able to close the box and not have my room feel like a rave from the 90s. And here you see what I was talking about. With a fluorescent tube in hand, I'm using the length of the tube to determine how long the box needs to be, taking into account the thickness of the front and back plate. The width of the box was determined by the width of the largest PCB my local shop had in store, plus a little extra needed for the drawer mechanism. Now ideally the reflector would be a parabola, but those are hard to make, and for my purposes astigmatism isn't really a problem, so I went with a circular reflector. The rough cuts I did by handsaw and editing saw. The rest I did on my bandsaw. And the saw is a cheap piece of shit, with blade guides stuck if tracking slightly to the left, and the wheels are so small they really give the blades a workout, but it still beats hand sawing. Now, you just saw me cut out the drawer, and now I'm cutting out the front and back panel, trying to keep a nice and even curve. Here we see the ready cutouts, and just to stiffen up the structure a bit, I would like a beam going across the top and slot into the front and back plate. So here I am measuring the beam to length. Everything you see is scrap pieces. I'm trying to avoid some blemishes in the wood, and now you can see me cutting the corners so that it will span the box and fit in the slots. The slots will then cut in the front and back plate. Here I'm only showing the back. Now, in order to give some extra support for the rails of the drawer, I made a small insert in the back that will also serve as a template for drilling the rail holes in the front and back panel, making sure they will align properly. And in case you're wondering, the rods are from the drying rack. I'll first drill a hole in the insert, as it will serve as a template. Then, using it to align the holes in the front panel, I'll drill one hole, and then use the rod to hold it in place while I drill the other one. For the holes in the drawer itself, it's very important that they are straight, and I would highly recommend a drill press or something similar, and mounting your workpiece in place also helps a lot. And since I didn't have a long enough bit the right diameter, I drilled as far as it would get me, and then with longer, though wider bit, I met the hole from the other side. And just to get a sense of progress and a feel for the final fit, I'm putting everything together. We see the insert being fitted with screws to the bottom plate, and the rods threaded through. Then the front and back plate just slips onto the ends. Then Video Magic conjured up a pair of side plates, and a copious amount of glue was applied to the sides of the box. I avoided the bottom since I didn't want to get the drawers stuck to the sides. The panels were then glued and clamped, and the same procedure was repeated for the other side. After the glue was all set and done, I started to work on the handle for the drawer. Using a hacksaw, I made some notches in the same kind of rod as the rails. The notches are spaced apart a bit shorter than the width of the drawer. Then with a vise to hold the rod in place, I bent the rod to 90-degree bend at both marks, making sure both bends are in the same plane. Then I marked off where the holes for the handle should go, and with a drill I poked 2 holes in the drawer. Then with a bit of tweaking the handle goes in place and was glued with epoxy when the box was painted. Now instead of the spring-like thing you might notice in the sketch, I wanted something with a firmer connection, and these connectors would work great if they had narrow spacing, but you can't always get what you want. But if you pry, you might find what you need. The reason for the change in plans was that the tension thing would not fit, and so I figured I would make a hole for the tube in the back. I pre-drilled the hole to get it in the right spot, and then with a spade bit I made it slightly wider than the tube. Now here I'm cutting out 2 circular pieces that will become the back mount for the tube. This is just a rough cut, so I try to stay well outside the diameter of the hole in the back plate, where it will fit later. I don't have a lathe, but with the drill in a mount and a threaded rod through the workpiece, I could at least get it round enough to fit the hole. A knife was closer at hand than a chisel, so yeah. And then I smoothed it off with a file and some sandpaper. It didn't come out all that pretty, but it works. Then we were back in the glue business, and the 2 pieces were glued and clamped. When the glue had set, I measured the width of the pins with the connectors in place, in order to cut a groove for the tube to sit in. I then cut it out on a bandsaw. Now, in order to keep the filament connector spaced, I'm cutting out a piece of plastic to sit as a spacer between the tube connectors in the groove. I then cut a slit for the spacer to fit into. For the tube mount in the front, I opted for a small block with the same kind of groove as the back, and here I'm just marking off the outline before it goes in the saw. A piece of plastic will serve as the spacer here as well. I then took the tube with the mounts in place and aligned it to the box. With the tube in place, I marked out where the front block had to go. Some glue was smeared to the back of the block with the spacer in place. It was then aligned to the markings made previously and clamped on. Here we can see how the tube is suspended by the mounts, and by simply removing the plug from the back, we can save us a tiny bit of hassle when we one day have to change the tube. Now the plug needs to stay in place, so here I'm marking out the small arm that will swing shut across the hole. The arm was then cut out on the bandsaw, followed by a quick sanding to round off the edges. I have a belt sander. That would have been a better tool for the job, but it was nowhere to be found during filming. I then pre-drilled a hole in the arm and countersunk it to give it a finished look. I then marked off where the holes of the arm had to go and drilled a hole for the screw to get some relief. The arm was then screwed in place. Now it's time to look into the electronic aspect of the build, and since I'm of the philosophy that you should not build it with others throw away readily, We're going to use the ballast from a fluorescent bulb I picked up at the e-waste at my local grocery store. There are two pairs of wires coming from the tube that are for the anode and cathode filaments, so remember how they connect, as you have to connect the tubes in the same manner. Other than that, as long as the bulb has a higher power rating than the tube, you should be good. If you're not familiar with how this electronic ballasts work, I'll put the link in the video description for a solid introduction to tubedrivers by bigClives. But right now, we don't even know how it works, just how it hooks together, and so we snip off the mains wire while we're trying to keep them as long as possible. I then drill a hole in the ballast so that it could be mounted to the back plate, and don't drill through any leads. I then marked off where the ballast would go and drilled a hole for the mounting screw. In order to insulate the board and not have it slip around too much, I marked off and cut out a small disc from a rubber mat using a pair of scissors. The ballast and the mat was then mounted to the back plate with a screw. Now let's start working on the high voltage side of things. I took two wires from some old flyback transformers, and these are way overkill in voltage rating, but readily available. I taped them together so they wouldn't move around too much. I then soldered the two wires to one pair of leads from the ballast, and I attached the connectors to the wires and placed them in the front tube mount. Then I soldered a pair of wires to the other pair from the ballast. These wires are probably from a microwave oven or something like that, I don't remember. But ends I attached the connectors the same way as the front and placed them in the plug groove. I then soldered on the mains live and neutral. One of them will have to be desoldered later in order to attach the relay, but right now I just want to see if the ballast even worked. And here I'm just putting the tube in place so we can test our ballast. And would you look at that? With a reflector and stopwatch you could call this a day, but we are not done yet. Now I wanted a lid, and I figured that lid would also be a good place for a display. So here I'm just measuring what size the lid should be and how large the hole for the 2 to 7 segment displays have to be. The holes for the display got down wrong, and it's definitely one of the biggest annoyances I have with this box. Now, in order to make a hinge, I took a piece of rod a bit shorter than the width of the box, and I cut a bit of thin cardboard to fit the lid. This was then folded over the rod and tightly pressed to the edge of the lid, and a copious amount of epoxy was used to bind the wood, metal and cardboard. This was then clamped between two pieces of wood to keep the rod aligned to the lid. With the epoxy hardened, it was time to make the hole for the display. I drilled a hole in each corner, and with a blade from a jigsaw I made a cut from hole to hole. As mentioned, it didn't turn out quite as planned, but there wasn't all that much of a plan from the get-go, so I guess I can't complain. Something about being able to measure them as many times as you like, but only cutting once. Anyways, when the hole was cut, I went over with a file to straighten out the corners. I then filed down the cardboard to be flush with the lid. It looks shit now, but it all goes away with a bit of paint. I then tried to guesstimate how large the circuit board had to be by laying out the larger components and giving myself lots of room. The protoboard was then cut to size, followed by me drilling a hole in 2 of the corners for mounting. Since the displays are connected to the soldering side of the board, I cut out 2 small stand-offs that were wedged under the displays. This gives a little extra room to solder the displays without melting the edges. Now, the circuit itself is quite simple. There's a relay to turn the lights on and off, 2 common anode 7-segment displays that are multiplexed by the 2 PNP transistors you see here. Each pair of cathodes from each of the displays are connected to the digital pin on the Arduino, and when the pin is set low, the corresponding segment of the currently high display turns on. But if you're unfamiliar with the driving of multiple displays, a quick Google search for multiplexing should get you on the right track. As you can tell from the ridiculous amount of wires, there was about the same amount of planning that went into the board as the rest of the box. Here I'm soldering the push button that will control the timer and connecting the high side of the PNPs to 5 volts. Now here's a quick tip on how to make a crooked wire straight. Pressed roll between two flat surfaces, the wire will come out straight as an arrow. This comes in handy if you, like me, prefer to bend wires to make your traces instead of using jumpers or pulling soldered traces. And after a few touch-ups and connecting the remaining leads, the board is more or less ready. Now I took 2 small blocks that will support the board onto the lid. These were mounted to the board with screws and then glued in place with epoxy. The lid was then mounted with 2 small blocks with holes for the hinge. These are actually not the ones that made it into the final product, but you get the idea. Still missing a hole for the button and a hole in the back for the power cord. But we will first look at the reflector. I actually wanted a proper sheet metal roof, but during the making of this box, every single sheet of suitable aluminum was gone, so I ended up using these lasagna trays. Not too pleased with it, but it's really cheap and it should not be hard to come by. In order to cover the entire length of the box, I cut out 3 bottoms of the trays. The edges of these were then folded up, trying to keep the height even. The sheets were then aligned to each other, and with the scissors I cut through the folded up edges with even intervals. The edges were then folded down in an alternating manner. Now, with the 3 sheets as one, I started to shape it over a PVC pipe about the same diameter as the width of the box. I then made a small indentation in both sides of the roof, and the same to the back side. The sheets were then folded back along those marks. Now the push button don't extend through the lid, so here I'm making a wooden extension that will fit between the button and lid and protrude out the front. The extension was cut to length and fitted in the lid. And since MDF looks horrendous as is, a coat of paint will do wonders to improve the aesthetics of the box. You know, I wouldn't say that it looks pretty, but I'm starting to think the slogan of this channel is that it doesn't have to. I don't show how it connects, but here's the 5V supply I got from a wall wart. And here I'm just mounting everything back after the paint had dried. The wires were then put in place with some zip ties, making sure the lid had enough wire to open. Then the hole for the power cable. The ballast and tube were then put in place and the remaining leads were soldered together. In order to shield the wires and don't have them absorb too much light, they were covered by foil tape. Finally, the roof was put in place with the same kind of foil tape as before. And here we have the final box. It is up and running, but the code still has a few bugs. However, I'm pretty pleased with its functionality. There's some kind of mount on the drawer for the PCBs would be nice, as I'm currently just using tape. Anyways, the video is getting quite long, so I think we'll leave it at that. Feel free to post any questions or critiques in the comments, and I hope you found this build useful. And as always, thanks for watching.